This by summarizing existing and ongoing QSSB supported soybean checkoff research. Part of that is collaborating on new national research trials. And recent examples of these have been foliar fertilizers and soil applied NNS fertilizers. Newer topics we'll be addressing in collaborative research include M fixation under various fertility regimes, the value of biologicals in soybean production, and soil health. And we've selected these topics with input from growers to guide future best management practices. And we take this information that's been generated in our individual states and through our collaborative research to amplify our impact into national extension initiatives. And this is what's supported by the United Soybean Board through our Science for Success project. I wanted to highlight a few recent examples of things that the Science for Success team have worked on. Last year, we released 3 extension publications using the knowledge gleaned from our previously conducted state level research on best soybean planting dates, how to pick the right row spacing, and soybean plant population densities. We hosted a webinar on these last year that you may have attended, and I wanted to re-highlight these as we move into the 2022 planting season. We also wanted to, as a team, highlight one of our recently successful collaborative research trials, which investigated foliar fertilizer use in U.S. soybean production. We were able to run a common research protocol at 46 sites across the U.S. that in 16 states. And so we captured a lot of environments of conditions in a short amount of time. And through this research found that these foliar fertilizers applied at beginning pod had no impact on soybean yield. And that could save US soybean farmers $4 to $20 per acre. The extension publication that we're going to discuss today that was distributed to attendees in advance of this meeting via email and will also be dropped in the chat right now, focuses on the soybean growth cycle and important risks, management, and misconceptions across the soybean growing season. And the way the webinar is going to flow today is we have panelists on from various land grant institutions across the U.S. who are going to briefly cover these various soybean growth stages and talk about one example for management and misconceptions from this document. We hope attendees have had time to look through this document at some of the other examples that have been provided and that those can foster some discussion during the Q&A. So there's about 20 to 25 minutes of content that's going to be shared shortly from this extension publication. And we are setting aside the majority of the time in this webinar for a lively Q&A session. So at this time, we're going to move into our first panelist, who's going to discuss soybean emergence. This is Dr. Michael Plumblee, the corn and soybean extension specialist at Clemson University. So take it away, Michael.
All right. Thank you, Rachel, for that introduction. And like she mentioned today, I'll be discussing kind of the growth stage, really from the time that we plant the seed through emergence. So in order to maximize yield at the emergence growth stage, really one of the most important things that we can focus on or try to do is get really good stand establishment. And what we mean by stand establishment is we want a sufficient final plant population that typically has uniform distribution. I wanted to pull aside a few things to consider with stand establishment that you can think about as we get ready to plant soybeans this growing season, with the first being plant into a well-prepared seed bed. We want to make sure that we get really good seed to soil contact. Secondly, plant at or around the optimal planting date for your region. And then third, select an appropriate seeding rate for your region. And we do have a few of the extension bulletins that Rachel's previously mentioned, highlighting some of those things. So if you're not aware of what these optimal dates or rates might be, we've got some generated information on that. In terms of management considerations for this growth stage, we just briefly hit on how important stand establishment is during the emergence growth stage to maximize yield So we really want to focus on doing the best job we can when we're planting. With that being said, we want to avoid areas that we might have to make a replant because we did not do something as good as we maybe could have with the initial planting. Typically, replants conducted at a later date can have a late planting date penalty associated with that. So in order to eliminate that, a few factors that I would say to consider with our initial planning would be first, proper setup of the planter and maintenance. There's been a lot of focus and research conducted on this across the United States in the past few years across commodities. And I think sometimes we could offset some of our issues by paying attention to the planter. Second would be residue management. If we're doing no-till, planting into a cover crop, or double cropping soybeans, which is popular down here in the South where I'm located, we want to make sure that we're getting the residue out of the way so that the seed can be properly placed into the ground. We want to plant quality seed, and then we obviously want to make sure that our planting conditions and soil temperatures are adequate for soybean. So I wanted to wrap up at least the planning to emergence growth stage with a common misconception and some reality to go along with that. One of the most common misconceptions with soybean is that if you obtain a suboptimal stand of soybean, so 80,000 plants per acre or less, this would call for an automatic replant. The reality of this is the cost of replanting can often be, rather expensive. And then if you add in the penalty of the later planting date with the associated replant, you need to weigh that option to make sure that we're not going to be less profitable than if we would have just managed the stand that we initially had. We also often see where visual stand assessment at the emergence growth stage underestimates the total number of plants that will emerge. So we may need to wait a little bit longer to get an accurate estimate of what our final stand will be.
Fantastic. Thank you, Michael. Our next speaker is Dr. Manni Singh from Michigan State University. And Manni is going to discuss some important considerations in the vegetative growth stages.
All right. Thanks, Rachel and Michael, to get us started here. So again, Michael got us started, we're planting the crop, what's critical after that, right? And there's a long vegetative period here, right? And the goal pretty much is we're building this canopy during this stage in order to maximize the sunlight interception that we need in order to develop and fill those seeds later in the season, right? So when we talk about this canopy, it basically means amount and distribution of leaf area in our fields. And you can see there an example of using leaf that canopy as a leaf area index by this green blue line in this image, which is pretty much acres of leaf area per acre of our ground area. And as you can see here, after this initial lag in the development, around V4 or so is where we hit this linear phase of development, where the crop is able to accumulate as much as 1 unit of leaf area on that acre basis on a weekly basis. And that correlates pretty nicely with this other line here, the crop growth rate, which pretty much is an estimate of the biomass accumulation, right? So again, it's helping us to set up the stage for that later seed fill that's about to incur. In terms of leaf area loss in this stage, it's not as critical. Some loss in leaf area, we will have a minimal impact on yield at this stage. The goal here, as I've listed here, is to maximize light interception before those plants begin the seed fill duration. So as long as we achieve that, we have the potential to maximize our yield. In terms of management consideration, again, early season, Michael was talking about some of these aspects already, right? We want to be scouting for early season pests, and there's a lot of regional differences in what we encounter, right? So making sure that we know what is happening out in the field, and we are doing a really good job with stand assessment. As Michael was again talking about those suboptimal stands, as long as they are uniformly distributed, it can help us still maximize that light interception and still produce high yields. During the mid-season, again, the scouting portion needs to continue, right? Because we are looking for any factors that can limit this canopy development and have a potential impact on seed fill and yield later on. For these late V stages, I will let other speakers talk more about this because there's a lot of overlap there, especially for indeterminate soybeans. But again, the goal is to maintain that healthy canopy, right? And not applying any products unless we are reaching some thresholds and the weather is favorable for some of the pest pressures. In terms of misconceptions, the one I would like to list here is, again, we are talking about canopy development, right? So a common misconception out there might be that if the canopy is not complete by beginning of flowering, there is a yield penalty to be expected. In reality, while it is desired to have the canopy develop at a faster rate, soybeans do flower over a longer period of time, right? Especially for the indeterminate types. So as long as the canopy is complete by or before that seed fill is happening, we are in a phase where we can maximize that yield potential. So again, we are setting up our crop, our plants to go into the seed fill at maximum light interception. And that's the goal we ought to have here.
Great. Our next speaker is Dr. Shaun Casteel, the Extension Soybean Specialist at Purdue University, who's going to talk about some considerations during soybean flowering.
Thank you, Rachel. So now we're entering into the reproductive stages. And so within this, each one of them are paired, right? So when we have an odd number, we're at the beginning or first, and then when we're at the even number, we're at that full realization. So today I'm talking about growth stages R1, first or beginning bloom, and then R2, full bloom. And so within the beginning bloom, R1, it's when you have any flower on the open on the main stem. And so the picture here I have on the left is a couple flowers out in the lower portion of the plant, and that's where it starts and works its way up. You know, these pictures are of indeterminate soybean. So if you count vegetative stages at V6, you know, it's just starting that point and will continue to work up. If you happen to go out and you see flowers on the branches, but not on the main stem, they have already occurred. They've already had flowers on the main stems. And so that's the first process and goes out to the branches. As you go into the full stage, R2, full bloom, this is when you have open flower on anywhere on the upper two nodes. And so that's where we're going to start concentrating, is on the upper portion of the plant. I particularly like this growth stage on our indeterminate soybeans because we've accumulated about half of our nodes. So I like to go out and count these nodes. And if we have a 9 or 10 trifoliate noded plant, I can double that. And by the end of the season, I'm thinking I'm going to have an 18 to 20 noded plant. Seems like it'll be a pretty good growth habit. Or if it's on the shorter side in terms of maybe 6 or 7, we're struggling a little bit. That's again on the indeterminate versus the determinate. You know, obviously we'd have all that vegetative growth first as we then enter into the reproductive phases. We can withstand a little bit of foliation at this point and still not have a major detriment to yield. As we move on, I'd like to consider a few other aspects of what's going on, right? What Manni talked about, you know, we have a very fast linear phase of growth as we go from vegetative to reproductive stages. So in particular, our biomass production, nitrogen fixation. So that's really getting up and going and has that linear increase, as well as accumulating the nutrients. Our job as producers of soybeans is to do as good of a job as we can to intercept the light, get that thermal energy to accumulate in terms of flower and pod retention. You know, the one thing about flowering is that, you know, a lot of people say, well, let's retain as many flowers as we can, but we typically lose 20 to 80% of our flowers already and still can yield well. And a lot of that comes down in the ability of the soybean plant to adapt, you know, based on growing conditions. And so, you know, even though, yes, we lose a lot of flowers, we still have good yield potential. As you look at management considerations, this R1, R2, that's a critical stage for a lot of the recent herbicides and technology. So want to be mindful of whenever we're hitting those stages, so then we're not off label, as well as the potential phyto injury that could occur. Within our northern latitudes, our northern states, white mold tends to be can be an issue for a lot of our producers. And so this is a prime area to go out and scout. Conditions that are prime for that. So think about the humidity, think about canopy coverage at that point, and whether we trigger a proactive fungicide application. This is also a good time to take leaf samples to monitor if you have nutritional needs or issues. And in particular, one that we handle in a lot of foliar aspects is manganese. And so there's fields from time to time that will need a manganese application as an example. We'll look at a few of the misconceptions that come with flowering. So a lot of people say soybeans are going to flower on the summer solstice. It doesn't matter when, it's that June 21st is going to flower, no matter what variety, no matter what maturity group or what planting date, but that's just not true. And so when you look at a couple scenarios, if we have an early planted soybean, they can experience the shorter days. And really what it's about is experience the longer nights before June 21st. And that's going to, cause the flowering to start in terms of that the primordial level is a small level, and then you have the potential to see them. On the other side, if you have a mid to late planted crop of soybeans, they're going to experience those shorter days or longer nights later, and they're actually going to flower after the summer solstice.
Our next speaker, Dr. Laura Lindsey, is the soybean and small grain specialist at The Ohio State University. And Laura is going to talk about some important considerations at pod set.
Thanks, Rachel. It's great to be here today, joining you guys to talk about pod set. So to really maximize yield, or things to consider at pod set, is the number of pods per acre. That really sets the maximum number of seeds you'll end up on a per acre basis. So this is really one of the most important stages in the soybean growth cycle. Stress will cause aborted pods, so you may see that. But if that stress is relieved later on at seed fill, you may have larger seeds that can help compensate for any of that pod loss. So for a management standpoint, I'd like to tell people to scout. This is a popular time to apply foliar fungicides or foliar insecticides. But those applications really need to be based on your state guidelines in scouting and knowing what's in your field. For example, when it comes to diseases, what is common in your region and what environmental conditions promote this disease? For example, in Ohio, we've seen more response to foliar fungicides in years that are wetter in May, June, and July. When it's hot and dry during the summer, we see much less yield response to foliar fungicide. So really only spray that foliar fungicide if you need it based on your individual state guidelines. The same could be said for foliar insecticides. Go out to your field and scout, and really only apply that when you need it. In terms of misconceptions, one that we worked on that Rachel mentioned earlier was foliar fertilizers. The misconception is foliar fertilizers will be beneficial to provide nutrients to the pods and impact yield. And in reality, we've looked at this as specialists across state lines, 16 states, 46 different environments, 2 years of data. And we didn't really see any yield benefit to a foliar fertilizer application, R3, in the absence of a nutrient deficiency. So as Shaun mentioned earlier, manganese is one we can see occasionally in Ohio. This would be high pH, high organic matter soils. There could be a benefit, but just application without a nutrient deficiency will not give you a positive return on your investment.
And we will end the content portion of this webinar with Dr. Seth Naeve, the Extension Soybean Agronomist at the University of Minnesota, who's going to talk about some considerations during seed set.
Good day, everyone. And I really appreciate everybody setting this up. But this is really the time when we're talking about building out that yield from what we've started with. So this is really kind of an academic point, but soybeans require really perfect environmental conditions without any sort of stress from pests all the way through seed filling in order to maximize yields. Of course, this doesn't normally happen, but I think it's a good place to start and think about what gets us to maximizing yields. That really requires perfect conditions all the way. So perfect conditions may be warm temperatures, moderate temperatures with abundant rainfall. And I would say coming from the north, warm nighttime temperatures as well. So what are management considerations during this time? the idea here really is to protect and maintain that leaf area throughout seed set all the way into senescence. And Manni really set this up perfect at the beginning about building this machine. So we've spent all year building this machine just for this time of year. So we've built this giant canopy of soybeans, and now is a time to support that and maintain that and allow that machine just to crank on and produce seed for us. That's where the economics come out of this. So in order to do that, we really need to minimize any kind of stresses. So those stresses would be anything both from an environmental standpoint, if there's any ability to do additional watering or anything like that, irrigation, but also from a pest management standpoint is really where we have the biggest ability to manage stresses. So in terms of misconceptions, I think this is a fun one, and I wanted to throw this out before we hit the question and answer period. But I think we're talking about a lot of discussion out there among industry about yield enhancing products. And as part of a USB project several years ago, we did a kitchen sink trial looking at some of these magical elixirs that produce soybeans, extra soybeans, increased pod retention, maximized soybean yields, allowed them to produce more than they would in any normal year. And our results were very clear to us, is that there really is not any such thing as any kind of a magical potion, fairy dust out there that we can add to soybeans that actually increases yields beyond their potential at any given point. Really, what does work for farmers is pesticides that are targeted to specific pests. So we're really talking about minimizing yield effects from damage from pest injury. So insects, diseases, weeds, etc. These are the things that really have function in the fields and really do well for us and help protect our yields. Thank you.
Thank you to Seth and all of our panelists for providing the audience with a brief preview of some of the information that you can find in our extension publication that's focused on this material. At this point in the webinar, we are going to move into a question and answer session. And to keep this lively, our moderator is Dr. Shaun Conley, the Extension Soybean and Small Grain Specialist at the University of Wisconsin. So at this point, Shaun is going to take over moderating the Q&A. Please utilize the chat function in this webinar to ask your questions. We also have some pre-submitted questions that can be used if we don't have a lot of activity in the chat to get this started. So at this point, I'm going to stop sharing this. I'm going to pin our panel and we will get going.
Thank you, Rachel, and good afternoon. I guess good morning, everyone. I guess it depends on where you are in the time zone today. So I think I'll start with the first question that came forward. And what I'm going to do is assign an individual to answer this, and I'll kind of go around the group here. And then after that individual answers the question, if anyone else wants to chime in, please do so. So I think I'll start with our first one from Josh Johnston, and I'm going to target this one to Seth Naeve, because I think this kind of falls into his area. Seth, what are the total amount of nodes determined in the soybean life cycle?
I'll just try to be brief here. So with our indeterminate soybeans that we're growing across most of the U.S., really the question really is when does our rapid seed filling start, and then that's a termination of our putting on new leaves. So it's really about a transition to seed filling towards the end of the year. So if we have the proper environments and temperatures and maturity groups, I mean, we can push this until quite late. And so obviously the easiest way to get more nodes is to grow longer maturities, but then this leads to problems with maturity at the end of the year.
Thank you. To follow up, Josh was actually asking, when does it actually happen? Can you assign a specific growth stage on average, Seth, when the total node numbers are set?
Yeah, the specific growth stage is actually R5.5. So it's halfway between R5 and R6. We get this little terminal, again, in indeterminate soybeans, we get this little terminal raceme of leaflets at the very top of the plant. That's right when things kind of shut down. And basically, this is when I would consider the rapid seed fill beginning, is at that stage when the soybean is basically transitioning from continuing vegetative growth into putting all of its energy into reproduction. So there's kind of a switch over at that time. And so I'm sure there's other nuances that others could add to that, but that would be all that I'd have to add.
Thanks, Seth. The next question, I'll point this one to Shaun Casteel because of his work with soil fertility. Question for you, Shaun, is with high fertilizer prices, some farmers are going with all liquid fertilizers. Is that a good idea?
Yeah, obviously, whenever we're looking at fertilizer prices, I think the place you really have to start with is to understand where your soil levels are already at. So doing a good job of taking soil testing and to see are they at critical levels or not. I mean, that's based on probability and responses. And whenever you say all liquid sources, I mean, there's a lot to that too, right? Are we talking about this is all going to all your macros? So are you talking about phosphorus and potassium versus trying to just squeeze a little bit out with a little foliar application? You know, you got to set the foundation. So what I go back to is, okay, good soil fertility. That's going to be your supplier of the phosphorus and potassium in particular. Obviously, you have other nutrients that come into play. When you talk about any other liquids, I think that's not going to supply the major needs that plant has. So make sure your soil fertility is where it needs to be. I think a lot of our fields we can actually go by in terms of having a fertility application this year because we've had good buildup and maintenance. The all liquid approach, I don't think that's going to handle our macro needs. It might be able to handle a few of the micronutrient needs if it is needed.
Thank you, Shaun.
Hey, Shaun, if I can jump in for a moment on that. Casteel did a very diplomatic answer on that. If you can get by with liquid fertilizer on beans, you can get by without fertilizer.
Yes. I agree 100%, Chad.
All right, I guess in this webinar, we're not pulling any punches today. So that's good to see. I like to see that. So next question. This would go to, I'll give this one to Manni. Manni, does stressing beans promote more branching to increase yield, either by some type of herbicide stress or by physically damaging the plant by rolling?
Yeah, so I mean, there's multiple aspects there, right? I mean, a stress can potentially, benefit the plant, but again, at the same time, it can cause a yield reduction too, right? And I can use the example of field rolling here. I mean, I've heard talks about people trying to roll fields after emergence, V2, V3, try to break the apical dominance. So you have those two branches coming out. But again, it can, if you break before the cotyledon, you have a dead plant in front of you, right? So that's, again, I think we got to be really careful implementing stresses on a plant that can potentially cause injury and can result in a yield loss there, right?
Laura, Lindsey, do you have any other follow-ups you want to comment on that from your work?
I was reading the questions. I wasn't terribly paying attention. I was reading what was coming down the pipeline for me next because I knew you were going to call on me. But I support what Manni says.
So just from my perspective here in Wisconsin, we had rollers come to the state about 5 years ago. And one of the challenges we have seen is when we roll these steep landscapes and we have these significant rainfall events where there's 3 to 5 inches, we see some pretty significant ruts and some that were so deep that physically a 6-foot person could stand in it and disappear. So that is one of the things you have to understand the landscape, the physical landscape of where you're rolling to also address some of these questions. So, okay.
Just to add to that, Shaun, we have seen growths that have relatively low plant stands. We have issues with the low pod height being too close to the ground. So there's a potential if we have fields in Michigan where there are rocks in the fields, and there is a potential to, again, minimize harvest losses. You can get your cutter bar close to the ground. So there are potential benefits there, but I think it's more about minimizing your harvest losses typically than gaining any extra yield by breaking that apical dominance.
Great, that's a good point. Chad, go.
Quick comment. We did some work with Cobra and some other herbicides looking at stress, did some physical removal of main stems. Back when John Orlowski was here working on that project. What we found out were two things. One, if we took out the apical meristem, the beans are more likely to lodge. So we got the branching to take place, but we also got lodging that came with it. So we had weaker beans overall. Secondly, we observed a yield increase by burning the beans in a dry year. We didn't observe it in a couple of years where we had adequate rainfall. And we think the difference in the dry year was simply we delayed our R1 date just a little bit. Not a bunch, but a little bit. It pushed it back a little bit, and it got it into when we had more favorable rainfall events for that 1 year. Maybe the flip side of that question is, since glyphosate supplies are going to be shorter this year, and you start looking at using some herbicides that'll cause some burn and things like that, I wouldn't be concerned about using any of those at all, as long as they're used according to label, the right rates and right times.
If I could quick summarize, I think some thoughts on the stress thing. I think the issue here is that stress can work if we know what weather we're going to have, if we're targeting a specific thing, if we want to reduce leaf area for dry conditions, if we know we're going to be dry. Something like Cobra is a great example of something that can kind of trim up that crop and do something physically to the plant that allows it to avoid that other stress later. These stressors are not something that adds yield on top of existing conditions. I think it's allowing a plant to survive through some sort of other stress. So, and it has to be a very specific stress. This idea that we can stress a soybean plant and then make it resilient to all kinds of random things that we might have come about during the season is a fallacy.
Excellent. Thank you all. Good question, and lots of good responses to this. So you are right, Laura. You are next on the list. So I'm going to set you up with this question. And this is a good question because I think there's a lot of differing opinions out there in the marketplace. So this question is from Iowa, and it could be for any state for that matter. When planting early, is it best to plant your late relative maturity beans first, then early relative maturity beans last? And I guess that's the question that I've been hearing out there. If you're planting early, do you plant your early maturity beans early or your late ones early?
Yeah, so the effect of relative maturity, kind of depends on your planting date as well. So I'm looking at our Ohio agronomy guide. What our recommendation is, regardless of your planting date, is to plant the latest relative maturity possible that won't die in a killing frost, which can be variable year to year. When we're looking at May planting dates in Ohio, so normal planting dates, really the effect of relative maturity is not that large. We see yield declines maybe in Northwest Ohio if we go to a 2.0, but usually there's some wiggle room there, a wide range where we can still maximize yield. As we plant later, that's where it becomes really important to plant really that latest maturing variety possible that won't die in a frost. And I can bounce this to Manni if he's paying attention. Hopefully he's better than me. I know Manni's been working on really early planting dates, so earlier than us, and that we've done with our relative maturity work. So I don't know, Manni, with those extra early soybeans, maybe in April, do you have a different recommendation?
So yeah, we have been doing work on planting dates in general, and specifically looking at this relative maturity idea. I think that question we were chasing, if we plant very early and if we don't change our relative maturity, are we still properly utilizing the length of our growing season, or are we going to underutilize it? Right? And what we are finding out, at least for our end of April, we're not talking about ultra early, for our early plantings, typically end of April, at max first week of May, we do benefit by going to a later maturing variety. And the way we are getting that yield bump is we are increasing number of nodes. We are getting more number of seeds per unit area, and we are getting a little bit longer reproductive phase. So we are able to maintain the weight of those more number of beans that we are getting in a unit area. So we are seeing that happens, but like once we hit like May, even I think May 10th or so, doesn't really make a difference. And we are seeing a lot of variability in the data that regardless of the maturity group, and the yields are pretty much there. And then I agree with your point on the late maturity that we definitely see not as much of a yield impact, but there's definitely a quality concern, and harvesting beans at time. Otherwise, you do get frosted, at least here in Michigan.
And I want to add something to this. So I think we also look at the maximum yield, but let's also look at maximum profit. And so a lot of people are trying to catch old market prices. So planting early, being early, enables them to catch that. And so maximum yield is definitely one question, but maximum profit certainly needs to come into it. We're talking, $17 beans now. So I think that's something that comes in our mind, as well as harvest efficiency and spreading that out, right? So then the time of maturity group and planting date certainly comes into, okay, when are those fields maturing? If we're planting all full season first, and then we come to mid to late, all of a sudden they're all ready about the same time. So think about the harvest efficiencies coming to this, as well as profitability.
Thank you all. Our next question will come to our friends in the South. I'm going to probably target Michael Plumblee first, but then Jeremy Ross and others, please chime in. Given the trend toward higher yields associated with indeterminate soybeans, should the U.S. be moving towards all indeterminate varieties?
So I think that's a really good question. And I think it's a question that's been asked a lot, especially in the South, where at least in South Carolina, we're predominantly growing determinate soybeans. And I know we all look out to the Mid-South and the Midwest and see bigger yields coming out of indeterminate varieties. Kind of my perspective on it coming out of South Carolina, some of the work that we've done looking at maturity group by planting date work is that, really when we've switched from a determinate soybean variety to an indeterminate here, we really have to change a lot of our management scheme. It seems like we really got to kind of be on top of them with a timely harvest. We typically get hurricanes in the fall and weather, and the indeterminates don't always weather as well for us as a determinate bean. And sometimes they just don't fit our production practices where we're trying to harvest other crops like peanut and cotton. Do we have time to get the combine out and harvest indeterminate soybeans as well? With that being said, some of the data that we've generated here, we don't see a real big difference in terms of yield in our typical production practices going from a determinate to an indeterminate in South Carolina. So with that being said, I know that out in the Mid-South, they were historically similar to us, growing a lot of determinate beans, and then they moved to this early soybean production system and started growing a lot of indeterminate beans. I don't know, Jeremy, what your thoughts are coming out of the Mid-South on that.
Yeah, so we had a 3-year project funded by the Mid-South Board, 2012, 13, 14, and it really kind of changed the way that we looked at maturity groups. And so in the past, we always told our producers, especially if you were in a double crop situation, 10, 15 years ago, we had over 1 million acres of wheat, and that's not the case today. So we had quite a bit of acreage that was, planted into double crop soybeans. And at that time, we said that we needed to plant your determinate varieties, group 5s, late in the season, because they withstood the, stresses of late plantings and things like that. But that study that was conducted in 12 to 14 really kind of changed the way, we thought about this. And coming out of that study, it showed that group 4s had better yields than 3s, 5s, and 6s. And I think, not only, the research that's coming out of some of the stuff we're doing, I think farmers are just seeing that, indeterminate varieties here in the Mid-South produce better. And just from experience and with the concentration of the genetics in those earlier maturing beans, we're just seeing more indeterminates. And so, I've seen a shift, going from 5s, on a third of our acres down to probably less than 5% of our acreage is planted into, group 5s or determinate varieties anymore. We're just seeing, that shift. And, right now, I think we're kind of stable. We're kind of in that mid-4s to mid-5s. And I think that's, pretty much for the entire Mid-South. And so that's the Boot Hill, Missouri, Tennessee, Mississippi, Louisiana, and Arkansas. And so that's kind of what we've been seeing on maturity groups.
Excellent. Thank you both. The next question, I'm going to target this one towards Seth. Is there a relationship between number of nodes per plant and yield? And do you see any differences in this yield component with and between varieties?
Yeah, the second part of that's a better question here, isn't it? So I'll probably need some help from my colleagues on this, but just to start, I think everybody really set the stage. I think Laura, Manni both mentioned some of these points about getting that seed set going and the importance of seed set initially. But the reality is soybean has this tremendous capacity to increase seed size. So in my experience, I would say that soybean is very, 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 very rarely yield limited by seed number. So basically what we end up with is conditions at the end of the season during seed fill that allow for maximizing accrual of yield in the seed. So that's just mass in the seed. So I think that's a good point back to these misconceptions that we've been talking about here, is this idea of, and I guess it was Shaun mentioned this earlier too, is that this question of pod retention, flower retention and pod retention is not really an important point for us. It's really this idea of maintaining good conditions for seed fill. And the second question of this is how that relates to soybean varieties and maturities. I'm sure there is a correlation. Certainly maturity groups has a big effect on this because we've got a different set of timings. We've got more nodes in later maturities. We have a potential for a larger window for seed filling. And so that allows us a greater seed number. The challenge that we've got with longer maturities is that we may not fully fill those seeds. And as a little anecdote, up here in Minnesota, we've done a lot of work with ultra late maturing soybeans, and we can grow up to group 4s in St. Paul. They get frosted, they're ugly, they're 6 feet tall, but we tend to have very similar yields with these very, very small seeds just because we have enough seeds. So it really shows me the capacity of the soybean to buffer itself as long as we have good conditions during seed fill, whether we distribute that seed yield over lots of seed or produce larger seeds. It doesn't make a huge amount of difference, but I'm sure others have other opinions on that.
Anyone else have any opinions? Well, that was a dumb question. I know all you have opinions on here. And anyone else would like to comment on this? If not, I will move on to the next question. And I think I will, Laura, you're up with this one too. I think this kind of fits into some of the things you see in Ohio. Do fungicides promote plant health in a way to increase yields, or is there no help from fungicides other than the plant's protection from disease?
Yes, we've done a lot of work here looking at R3 applications of fungicide, probably 30 different environments over years in Ohio. And really the trend is when we see disease, we see a yield increase, or maybe we'll say we protect yield. I'm not sure which way we want to look at it. But when we see disease, that's more likely where we see a yield response. And I know there's some, maybe others who have seen plant health responses, but in Ohio, it tends to be when there's disease. And the two that we've seen the most have been frog eye, leaf spot, and brown spot. And those are where we have that fungicide response in general.
Shaun, can I say something here from the northern region?
You're always welcome, Hans.
Yeah, so thank you. I'm representing North Dakota, and I was just presenting on this topic for our region, and I'm including kind of Northwest Minnesota. So we have very few leaf diseases. And so if you then, for prophylactic reasons, apply a fungicide, I just analyzed some data from 2004 to last year, and we had over 90 trials. And out of those trials, only 8 out of the 90 comparisons that were various trials, various products, only 8% saw a significant yield increase. That didn't even mean that it paid for itself. So for the northern location, when you don't have diseases, just a prophylactic application is probably not going to be profitable. But again, but Laura said, if you have disease, then it is.
Hey, Shaun, I'll give a Mid-South perspective. So our entomologists and plant pathologists actually did a study funded by our promotion board, and they actually went out and did large strip trials on a number of farmers' fields, production fields. And over the 3-year study of that, it was a 50-50 shot. Half the times the automatic sprays paid, and then half the times our normal, scout and spray when we meet thresholds paid. And so after digging a little bit deeper and looking at like the varieties that were planted in these fields, where we did see a response with the automatic sprays were where we had varieties that were not very, didn't have very good resistance. The defensive packages in these beans weren't very good. And so, from that, I tell my farmers, to look at, beans that have really good disease packages and, resistance to diseases. And you may be able to eliminate these, automatic applications. We've got a number of farmers that just do it just because. But, the data that we have is a 50-50 shot. And then, of that 50% that where we saw a response, we had, plants that had, less disease resistance. And so that's kind of what we've been preaching here in the Mid-South.
And I'll add to that, there was recently some collaborative research done by soybean pathologists and agronomists from across the US that looked at the impact of foliar fungicides on yield. And they found there were circumstances where you were more likely to see a positive yield response from using foliar fungicides. That was often when later planting dates were used or at lower latitude. So as we think about the impact of these foliar fungicides on yield in this webinar, which represents growers from across the United States, we might see more of a positive yield response from using foliar fungicides in the South because our disease complexes are different and our season is longer.
Thank you, Rachel. I think that was an amazing paper. I can't remember who the co-authors on that were, but never mind. Anyway, our next question, Shaun Casteel, you're up. In a high yield environment, can you see yield response to adding additional nitrogen?
Oh boy, nitrogen and soybeans, that's been a topic for decades, right? And so this idea of, pushing the yield level higher. And so, every now and then you can do that, but is that a recommended practice? I really don't think that's the place to go with this. We've got high yielding beans that are, 100 plus bushel that everything was there from fixation. And so what you can do to establish good root development, good nodulation and fixation to supply that nitrogen need is certainly the starting point. High yielding environments, that's going to be pretty relative, right? What's high yielding environment in the north versus the south, and what's organic matter supply? I've certainly seen some interactions with, let's go with earlier planting dates and cool soils and limited mineralization. So they might have some benefit of there. That's not one that I would turn to every time. I've obviously had some results not everyone has in terms of the sulfur side of this, and the sulfur to supply to be a cofactor for nodulation and then fixation. So I think that's really when we talk about this nitrogen topic and high yield, it's what can we do to help establish a good root system that has nodulation to supply that nitrogen. Once we've established that, I think the top end is still there, even when we're talking 100 plus bushel in those very high yielding environments.
Thank you, Shaun. Anyone else want to tag into that? All right. If not, I think I'm going to stick with Casteel as our resident soil fertility person or specialist on the soybean side of things. And because I don't have any idea how to answer this question. Any yield response from humic acid in furrow on low or organic matter soils? Have you seen anything out there about that, Casteel?
I personally haven't I've done in-furrow work. I haven't done it with any of the humic products. I have not seen anything on that. So I would definitely be open to anyone else that's looked at this. I mean, concept you can kind of understand, but I haven't seen anything personally and have not looked at it within my in-furrow work. So my answer is pretty short on that.
We've looked at it a little bit, but haven't seen a yield response with the rates that they're recommending. And I'll leave it at that.
Yeah, I've done some just soil applied rates that I haven't seen anything, but I haven't done anything intro, and the soil applied hasn't seen a response.
So I think we might have answered this question, but I'll kind of bring this back out to the larger group in general. And this is there any peer-reviewed evidence that fungicides increase yield in the absence of disease? If so, is the mechanism known? Basically, I think it's getting back to that whole plant health related question.
I don't know of any, but I'll just jump in since nobody else is jumping in. So I think part of this question comes around because we do see a little bit of stay green in the north. So Hans did a really nice job encapsulating the northern, and I totally agree with his perspective. We see very few foliar diseases. I'm no pathologist, as my disclaimer to begin this, but I will say that it's very possible that sorry.
Well, apparently we know who let the dogs out, and that would have been Seth. So, well, while we're waiting on that, I'll
make a comment real quick, Shaun, on that. And if you remember looking early on, the plant pathologists used to do those little piano charts where they would show yields from various studies and the scales, and they typically showed yields that went from the negative over to the positive. And in those studies, the level of disease sometimes was all over the place. So I'm sure that there's some instances where fungicides have potentially caused a slight yield increase, even when disease based on scouting has been limited. But if I'm not mistaken, from our pathologists, usually that never gets into the realm, or I shouldn't say never, it rarely gets into the realm of a return on investment for the fungicide.
Thanks, Chad. Here's a good question. I'll open this up to the group to see who's worked on this. How might no-till planting soybeans green into cereal rye affect soybean yield? And then the next question with that, would this be a recommended practice if cereal rye and weeds are adequately controlled?
Well, I can answer a couple of questions here. So I've worked with planting rye after small grains in the fall. So you plant it in September, and then you come back the next spring and you plant soybeans in it. Now, it can work very well if there is enough moisture. And then you terminate, for instance, the rye with a Roundup application, and then the soybeans just keep on growing. So that it can work, but if you have a drier season, like last year we had a drought condition, then the rye will utilize some of the moisture, and then we saw a negative effect on the yield. So you need to monitor the conditions. So especially in a wet year, it is ideal because then the rye will suck up some moisture. So it is conditional, depending on what you find, what you have to decide on when to terminate the rye. So you can terminate the rye before planting soybeans, and then you would have very limited issues. So can you plant green? Yes, if the conditions are right.
Thanks, Hans. And I actually I can comment on this myself. I've been involved with a project funded through the North Soybean Research Program, NCSRP program, looking at actually planting green. And generally what we've kind of found, it's roughly 80% of the time, again, related to soil moisture question that Hans brought up, we really don't see much of a yield hit on the soybean side and drier as we tend to. One of the interesting things that we're looking at then is kind of timing our planting date with maximizing, in this case, cereal rye biomass to fix carbon. And then also, how does that relate with weed control? Because we're seeing some challenges specifically in the South, and there's a couple of you here that understand that, trying to manage the glyphosate-resistant water hemp or palmer that we see in the southern part of the country, that we're using the cover crop in a sense as a weed control option. So I think there's some interesting work coming down the pipeline to really look at, maybe we might take a small yield hit on the soybean side of things. The numbers I've seen is 2 to 4 bushels. However, how does that influence the weed management program and saving that money in the back end in terms of actually controlling those weeds and not putting that weed seed back into the system? Because I don't know, not as up on Palmer, but I know water hemp, for example, is that germination is stimulated by light. And if we have a significant amount of biomass out there, we just don't generally see that germination as evident. So we can kind of manage that, at least in the soybean system, and then move into corn where we have more herbicides available for control. So I'll pause with those thoughts. If anyone else, Jeremy?
Yeah, I agree totally what Hans and Shaun said, but we all know when we make some major changes in our production practices, we see more problems. And so here in the Arkansas, the Mid-South, the biggest thing we've seen the last 2 years has been slug infestations. And so we plant into green, the slugs are there. We have a fairly wet spring. Soybeans start to come up and the slugs, are just decimating our stands. And so, we're trying to do some research and look at, trying to control that. But, currently our recommendation for the University of Arkansas is to, desiccate that cover crop at least 2 weeks prior to planting to kind of kill that, that green bridge. But we've got a lot of farmers or, some of the more aggressive farmers in cover crops still plant into green, and they do have some of these problems. But, I see that, the advantages, the disadvantages of planting into green, but, there's still a lot of things, especially in the Mid-South on cover crops, we still need to try to answer. And so it seems like every year we get something odd that comes up.
Hey, Shaun, if I could jump in briefly on that too. What Jeremy hit on is spot on. The slugs have been a massive issue for us the last 3 years, and we're a large no-till area, this whole region. Our weed scientist that's looking at cover crops and probably on some of those projects with you, what she's seen so far, Erin has seen that even if we go late like this individual's proposing, we are suppressing some weeds, particularly winter annuals in our case, and maybe some of the weeds that would germinate early in the spring. But we're not decreasing the number of herbicide applications we need in the field. So it's not replacing the herbicide use. It is getting us good control of the weeds that are out there. But I'll also echo what Jeremy's mentioned. We've been bit, no pun intended, pretty hard the last 3 years with slugs in our area, to where, Jeremy, we're actually telling people to terminate earlier. If your primary goal is success of your cash crop, then we're telling folks to terminate earlier to let that residue melt down a little bit quicker and potentially have less problems with some slugs and things of that nature.
Thank you.
Some of our work.
Go ahead, Shaun. Sorry, go ahead, Shaun.
No, I just want to make one other comment on this cereal rice. So whether it's planting green or like Chad was just talking about, terminate, 2 weeks ahead and it's only 16 inches tall, you do have a buildup of carbon, right? There's benefits of that, but that also has had some supply issues with our nitrogen. And so we've actually seen some immobilization of nitrogen. So had some limited growth of our soybeans and nodulation, where we've overcome that with, go back to the fertility aspect that I come from, we have overcome that with some applications of nitrogen and sulfur in that way to overcome what's being immobilized, as well as probably cooler wet soils.
Thank you. So we've actually came to our normal stop time. However, there's a lot of questions still in here, which is fantastic. So for those of you that need to leave early, I'm going to turn it over to Rachel for some comments, and then many of us can stick around after the 1 o'clock hour. So Rachel, the floor is yours.
Fantastic. So for those of you that have to hop off, we just wanted to share couple more logistical details here. So all of the information that was referenced throughout this webinar that has been generated by our Science for Success team is available on the Soybean Research and Information Network website, which will be dropped in the chat. So please visit this resource to get our information. And the main thing I wanted to share here as we come up on 1 o'clock is this QR code that you can scan for CCA credits for attending this webinar. There's also going to be a short survey distributed out to attendees. We'd like to collect some information from you on how you thought this event went today and any future topics that you'd like for the Science for Success team to address in these webinars or in other formats. So for anyone that has to leave here, has another meeting or obligation, here's your opportunity for the CCA credits. And at this point, I'd like to turn it back over to Shaun. We're going to answer questions for the next 15 or 20 minutes. And so if you can stay on, please stay to engage with these specialists.
Excellent. Thank you, Rachel. All right. So
and can I jump in here, Shaun, since we're wrapping this up? I've already got a couple emails directly to me, so I just want to throw this out to anybody that's still hanging on. That if you do have continued questions, be sure to reach out to any of these specialists. They'd all be happy to reply to you. It doesn't matter your state boundaries. In fact, Shaun answers questions for all over the U.S. He's happy to give recommendations to everybody as long as it includes planting early. So I'll turn it back to Shaun.
Thank you, Seth. And I resemble those statements. So I appreciate that. All right. Next question. All right. Hold on 1 second. I need to remember where I was at here. Okay. I'm guessing this is a question from Mark Seaman, but this is from Michigan Soybean. He had read that soybean maturity ratings may affect timing of flowering, i.e. longer maturity soybeans may be triggered later to flower than shorter. Do you have any thoughts on this? So.
Yes, is the short answer, but it also depends on when they're planted. So if they get planted later into the season, the whole time from planting to flowering gets compressed. So and like in double crops, for example, that we do a fair bit here, the windows really tighten up a fair bit.
Since we're on this kind of misconceptions thing, I'd like to just chime in here on this, is that there's a lot of people really get all wrapped up around flowering. I mean, there's really good reasons to pay attention when we hit R1 and R2 for pesticide applications and labels and things like that. But for yield formation, it really, in the north, it really plays really little impact on our total yield. As I mentioned 3 or 4 times, everything happens at the end. We all talk about September, October, or August, September makes soybean yields, and that's really the case. Those early flowers, very few of them set pods. So I think the focus really is on vegetative growth at that time. So it's great to know when we're flowering for good reason, but if you really want something to do something, ask that soybean to put on a couple more leaves.
Excellent.
I think to Seth's point, again, we're double crop. We're 30 to 40% of our acres, we harvest wheat and then plant beans behind it. And so most of that wheat's coming off in June, right? So there are some beans that we don't get planted until June 21 in that scenario. And yet, if we've got good weather, particularly in August, then we can get phenomenal yields off of that. So we can still get 50 bushel yields in good fields on a late planting date like that. So, and I just playing around I looked at Georgia today, the drought index in Georgia over the last 10 years for July and August, 5 of those 10 years, they've had a drought. I look at the drought index for Wisconsin or for Kentucky, we haven't. So there's some differences in there. And I think part of this early planting date and while there's a focus on the summer solstice and such, I think a lot of it is you're just avoiding some really hot, really dry weather in that process.
So Chad, I think some farmers in Wisconsin would argue that we've seen a couple droughts in the last 10 years, but that's just what we say here. All right. Next question. This is for before, I'm going to point this one to Hans, and then I will go to Jeremy because I think this is a good question. Do ultra narrow rows give an advantage for light interception?
Yeah, that's an excellent question. And I guess it depends again where you are in the United States. In our northern region, definitely the narrow rows always out yield the wider rows. And I'm talking about anything that is 30 inch. I say, don't do that in North Dakota because it takes too long for the canopy to close. Our beans aren't that tall, so we don't get that interception. We've always talked about that canopy needed for a maximum interception. So if you narrow the rows, that means you get more plants per unit area, or more evenly distributed anyway, and you get more light interception early in the season. So for northern regions, 30 inches too wide, we need to be 22, 15, and even 7. And if you look at all the data, the 7 will out yield the 14 if you plant them the same planting rate.
Yeah, I would agree with Hans. And, here in Arkansas, we're kind of unique because, we have anything from 7.5 inch drills to, 38 inch planters. And so we pretty much cover every row spacing you can think of, in soybeans. And it really all is dependent upon what other commodities you have. So a majority of our drilled beans or 30 inch rows are rice farmers, and so that's 1 million plus acres. And then, the cotton guys are going to be on wide rows just because their cotton is going to be on wide rows. And so if we've done quite a bit of row spacing study here in the Mid-South, and anything less than 30s, you see a yield advantage. But if you look at the grow for the green, everybody is on wider rows. Nobody is on really ultra narrow rows, but a majority of the guys that are breaking 100 are on 38 twins. And so I would consider a twin row system narrow rows, because you're taking that single 38 and spreading it out another 8 inches or so and giving a little bit more area coverage. But I definitely, push for trying to get away from a single 38. We see yield advantages trying to get away from those. And I always say anything less than 30s, you're going to see a yield advantage. And so I've got several farmers that have kind of switched up their row spacings over the last few years and have seen, that benefit by going a little bit narrower just on their production over the last 2 or 3 years.
Shaun, a quick comment from the data. We have looked at the narrow row spacing. What was asked was, okay, if you're planting early, now you have a longer season in front of you, and are you still going to benefit by staying with narrow rows? And we have done 15 versus 30 and early planting, end of April here in Michigan. And we did see that benefit was there. There was a lack of interaction, that the benefit of narrow rows that Hans and Jeremy is talking about was consistent even with our early plantings too.
Can I chime in real quick? So bringing it back to the USB supported really nice kitchen sink project years ago. One of the treatments that we included with this maximum yield study, where we were really literally throwing the kitchen sink at these soybeans to try to maximize yields at a time when, Kip Colors was getting 130, 40 bushel yields. Farmers were really interested in this. They really wanted to know what we could do to drive yields. The number one thing that produced yields the most with the highest frequency and the largest numerical value is narrow rows. And that was across the whole US, 60 site years of data across 3 years. And of course, what do farmers do? They move in the north. We've seen a movement towards wider rows over the past 10 years. So, if there's a real commitment to increasing yields, we would see it with narrowing rows, but we don't. But it does play to the idea that this Jeremy mentioned this, it has to fit with the system. So farmers have to do what they need to do. And if they want to plant with a 120-foot wide planter, they're going to have to go with wide rows. I get it. But if they really want to maximize yields, narrow rows are the best way to get there. if they're not limited by equipment use. And I think going forward, I think the interesting side of this narrow row question is really around weed control. And I think we're either going to see farmers using cultivators in wide rows, or we're going to go to narrow rows for better canopy closure and better coverage and reducing weed escapes that way to manage weeds from that perspective. And it may be that weed control trumps all these other discussions, unless Bayer adds 6 more traits onto their platform.
We see, our 15-inch rows typically close 3 to 4 weeks earlier than a 30-inch row. And so just bringing that question about light interception, you talked about weed control, that suppression, that's a part of it, whether we realize it or not. That's a major part of that yield advantage, as well as moving forward with weed control.
Thank you. I think we have time for, we're going to do 2 more questions. And then what we're going to do is then we're going to drop the webpage at the Shrin website that has the email addresses to all the state specialists that are on here today. That way, if there's follow-up questions, you can contact them directly, and it has a nice resource here for everyone in the country that works on soybeans. So the next question is from Pam Smith. I'll throw this out. I think I'll throw this out to Seth, just because I know he kind of works in this area a little bit. How much of the yield increases that we are seeing these days is associated with genetics, and how much is associated with management? Basically, who gets the credit, is I think Pam is asking.
Yeah, I'll let some of the folks that have actually done a better literature review in this area back on this. I think there certainly we can take credit for a big chunk of this as agronomists, but the breeders have done a tremendous job of this, and I think yield stability really shows. In just looking at the last few years, what we see, especially when we look at U.S. and South America, because it's kind of in the news with their tough conditions this year and everybody's speculating on yields. What I've seen is that our yield stability is much greater. The bottom end is really brought up. We have better yields under poorer conditions. I think we haven't gained as much on the top side in terms of from a breeding standpoint. But that's kind of what I see when I look at the data. And to apportion it, I guess I'm not willing to really step out and say percentages on either side, but I'm sure somebody else is willing to go there.
So I do know that some of the work that we've seen, I think Jim Specht would have done this. This data might be a little old now, but I believe the numbers that he associated were roughly 50-50. 50% of the yield gain has been due to genetics, 50% from agronomics. And that could be anything from, seed quality, row spacing, weed control, anything along those lines. And again, we all know breeders, we work with breeders, and I think they would like to claim 99.7%, if not more, of the yield gain was because of breeders, but I would argue we're at least 50-50.
And the one caveat, there's a third piece, is that's environmental change. And we've seen big changes in weather conditions in these regions that have actually been quite favorable for soybeans. So there has been some recent publications on the effect of changing climate relative to extending growing seasons, especially in the north. That's been a benefit for us. So I know we're getting where there's a lot of discussion about this, and that's a big topic, but we may have to break it out into G by E by M.
Shaun, I'll try to answer very quickly on that. So I was trained under a breeder, so I'll give breeders a lot of credit, of course. But at least from what I've seen in Louisiana, is when the majority of the planting went to 4s, 4.5 to 4.9, and we're planting earlier, there was a huge jump in yield. So I think a big part was moving earlier maturity groups and planting earlier was a big jump.
Thanks. Thank you, David. And your bias is noted.
Hey, Shaun, I think it's a great question. It's one that really the most important reason that it's asked is for people writing grants to show how much good they're doing in their area. The reality is you need all of it to increase yield, right? If you've just got the good genetics, but you don't have good management going along with it, updated and as weather patterns change and production practices change, or not the practices, but the ability to farm larger acres and all that stuff. If we don't keep adjusting along the way, then we don't get to better yields. It'd be like saying, was hybrid seed corn, or was fertilizer nitrogen, were herbicides, or were the tractor? Which one of those was most important in increasing yields in corn? You don't do it without all of them.
Chad is always the best diplomat on this entire screen, so we always fall back on him as our administrator in training. So I think what we'll do, and I don't want to stop this great conversation, but I think we're backing up against people's schedules and times. Rachel, if you're willing, you read my mind to pop up the scan for the CCA credits. I do notice a few people were unable to do that, and I'll turn it over to Rachel for final thank yous and goodbyes.
Great. Well, we appreciate everybody in joining us today for this very lively discussion and excellent Q&A session. And I think this provides our Science for Success team energy to continue to do this due to the lively Q&A session that we just had. Before we conclude, I do want to thank Jenny Carlio, who's an area specialized grain agent here in North Carolina, who's helping with some administrative aspects of the Science for Success team. And she's a large part of why this webinar ran smoothly today, as well as the help of NC State Extension IT. So with that, we'd like to thank all of our panelists. This webinar really showcased the strength of our Science for Success team from across the United States. Attendees will receive a link to the recording and information for the resources that we discussed today within a week. I will again emphasize our Science for Success material is posted on the Soybean Research and Information Network website, as well as through our local extension channel. So we appreciate everyone joining us today, and we hope to see you at the next Science for Success event.